Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 16, Atoms, Molecules, and Ions, Part 3. Here are our objectives for today's video. Pause here. So some of this logically makes sense. So groups or families, these are columns, so meaning we go from top to bottom. They are called groups, and they tend to have common properties because they have similar electron configurations. And then rows are called periods. They share quantum numbers, but in general, you won't see other sort of similarities between elements that are on the same period. Pause here. All right, so some of these have names that are specific to them. Some of them are just named from the element at the top of the group. So group 1, so that's what starts with hydrogen, sodium, all those. Those are the alkali metals. Group 2, so that's magnesium, beryllium, all those. Those are the alkaline earth metals. We skip the D block. They're just the transition metals. And then skip over to 3/13. So you'll sometimes hear it called group 3A. Sometimes I'll just call it group 3. Sometimes you'll hear it called group 13. It doesn't really matter which of the three you call it. That's the boron group. Then we have the carbon group, nitrogen group, oxygen group. Moving over to the group that starts with fluorine, those are the halogens. And then we've already talked about the noble gases because we use those in our electron configurations. Pause here. All alkaline metals, they have only one valence electron, so they all end in S1 for their electron configurations. These explode in water because those electrons are given off into the water, and that's an extremely exothermic reaction. The word alkali or alkaline just means basic. When this reaction happens with water, meaning these electrons are transferred from the metal to the water, they form a basic solution, and they tend to be soft and silver in color. Pause here. Alkaline earth metals, these all end in S2 with their electron configurations. These are reactive when they react with water, but they're not explosive. So for example, if you take some metallic magnesium and you place it in water, you'll see a little bit of bubbling, and the solution, meaning the water that's left over, will be alkaline, but it's not nearly as exothermic of a reaction as the alkali metals. Pause here. These all have 7 valence electrons once I exclude the D or the F. The reason why I would exclude the D or the F is because those do not tend to participate in covalent bonding, meaning they're not really impacting the chemical properties all that much. So halogens can be solids, liquids, or gases, and they tend to form acids when they react with water. You've probably worked with hydrochloric acid by this point in time in your chemistry career, and all halogens can form similar acids like hydrofluoric, hydroiodic, hydrobromic acid. Pause here. Then we have the noble gases. These all have complete valence shells, so I've got no unpaired electrons. All of these are gases, and all of these are inert. All that means is that they're not reactive. That's not to say that they can't react, it's just that they're not likely to react. Well, actually, some of them can react, some of them can't. We'll talk more about that later in the year. Pause here. All right, so these are just some common ion charges. This is something that you could logic your way through, but admittedly, it's going to be easier to have memorized just because it's something that comes up so frequently. So things that are group 1 tend to take +1 charges. Group 2 tends to take +2. Aluminum tends to take +3, or the aluminum group rather, boron group. Carbon usually doesn't take a charge, doesn't often form ions. Nitrogen group forms -3, -2, fluorine, and it's cut off, but the noble gases don't tend to take a charge. Essentially, this is just explaining what charges something has to have in order to obtain a noble gas electron configuration. Pause here. And then we're just going to talk a little bit about the F block. We're not going to be doing too much with them. So the first row on the F block, these are the lanthanides, and the second row is the actinides. These are, a lot of them are synthetic, meaning that they don't exist naturally. They're actually made in labs, and they have really interesting optical properties just due to the partially filled F subshell. We're not going to be talking too much about them, but I just wanted you to have seen this at some point in time. Thank you so much for watching, and have a great night.